Okay, ladies and gentlemen, so today we're going to continue with the evaluating trigonometric functions of non-acute angles, specifically how we would or find a evaluate an angle that is negative in this case. So in this case, we have the negative, we're being asked to find the cosecant of negative 210 degrees. Now, the steps involved are pretty much the same as they were in the previous video. The first thing that we're going to do is find the smallest possible positive coterminal angle. So if we have negative 210 degrees, what we want to do is we want to add that to 360 degrees. And once we've done that, once we have the smallest possible smallest possible positive coterminal angle, what we want to do is we want to find our reference angle. So if you add negative 210 plus 360, your answer is 150 degrees. So 150 degrees, it's much simpler to find the reference angle. So what we want to do is we want to draw that just so we have an idea of where, visually speaking, of where the terminal side of this angle will be. So we know that the initial side is here. And the terminal side of 150 is in quadrant number 2. Now, if you remember when we did our video on reference angles, we said that to find the reference angle, all we had to do, and if the terminal side was in quadrant 2, all you had to do was subtract 180 minus z. The formula was actually in class we discussed it. It was alpha equals 180 minus z. So we're going to subtract 180 minus 150, and of course we know that our angle is 30 degrees. So our reference angle is actually 30 degrees. So now that our reference angle is 30 degrees, let me fix that up. So minus 150. Now that we know that our reference angle is 30 degrees, and we know where the terminal side of that angle lies, it's easier for us to know if the value of the cosecant of negative 210 is going to be positive or negative. So always remember our trick. All students take calculus, which means that all trigonometric functions in quadrant, if the terminal is in quadrant 1, all trigonometric functions are positive. Students, meaning that if the terminal side is in quadrant 2, then the sine and the opposite of the sine, which is the cosecant, would be positive and everything else will be negative. Take, which means that in quadrant 3, all trigonometric functions are negative except the tangent and the cotangent, which is the opposite of the tangent. And calculus, which basically states that all of trigonometric functions in quadrant 4 are negative except the cosine and the opposite of the cosine, which is the secant. So now that we know that, ladies and gentlemen, what we're going to do is determine. So if I'm being asked to find the cosecant of negative 210, and after I found the coterminal, I realized that the terminal side of the angle is on quadrant 2. That means that if I'm being asked to find the cosecant, which is the opposite of the sine, that means that the value is going to be positive. So now that I know that my reference angle is 30, I am going to actually be looking for the cosecant of 30 degrees. Now remember, ladies and gentlemen, that the cosecant, you can use an identity function, or we can say, in other words, is equal to the sine of, is equal to 1 over, in this case, the sine of 30. So if I'm going to look at my cosecant, or if I'm going to look for the cosecant of 30, I'm going to use the function that says 1 over the sine of 30. And then what I'm going to do after that is just find the sine of 30. And I know the sine of 30 is 1.5, so this is actually going to equal 1 over 1/2. And whenever you are dividing a fraction, you are actually multiplying by the reciprocal. So this is actually going to turn into 1 times 2 over 1, because that's the reciprocal of 1/2, or 1/2 upside down if you want to look at it that way. And that is going to equal to, of course, 2. So that means that the cosecant of 30 is 2. So since 30 is the reference angle, that ultimately means that the cosecant of negative 210 degrees is actually positive 2. And that's pretty much how you do that example. This is example number 7 in your textbook. So you guys can go ahead and make reference to your textbook there to find that. And we said that the cosecant of negative 210 equals 2. Now in our next example, we're going to be given a value of a trigonometric function, and we just have to determine in which quadrant it's located. So I'm going to go ahead and clear this real quick. And we're going to look at the other example. And the other example says, which is example number 8, is actually asking us, excuse me for a second, ladies and gentlemen, seem to have lost the page. Here we go. Example number 8 says, or is asking us to find all the values of z. So we're going to look for all the values of z where z is greater than 0 degrees. So z is going to be greater than 0 degrees, or 0 is going to be less than z, however you guys want to look at it. And z is less than or equal to 360. And z is less than or equal to 360. And they want us to find the sine of z. So we're looking for the sine of z. Sine of z when, or the angle, we're actually being asked to find in which angle is the sine of z equal to the negative square root of 3 over 2. So now we're being asked to find which angle has a sine of the negative square root of 3 over 2. So we're going to do this in 3 steps. The first step is to determine in which quadrant is sine negative. So again, we use our all students take calculus abbreviation to see in which quadrant, in this case, is the sine negative. So in quadrant, it's not here, because in quadrant 1, all angles are positive. In quadrant 2, the sign is positive, and I want to know where the sign is negative, so it's not quadrant 2. In quadrant 3, the only positive trigonometric function is tangent, so obviously it's 3. And calculus, which is 4, that means that in quadrant 4, only the cosine is positive. So where is the sine negative? According to this, sine is negative in quadrants 3 and 4. So we know that the angles that we're looking for are in quadrant 3 and quadrant 4, specifically quadrant 3, and quadrant 4. Okay, quadrant 3 and quadrant 4 is where the sine is negative. So that means that the angle must be in quadrant 3 and in quadrant 4 specifically. So we know that we did that much, right? We know that the angle is going to be, or that sine is going to be negative in quadrants 3 and 4. Second step is to calculate the absolute value of the negative square root of 3 over 2. Now, why am I going to do that? Well, because I know for a fact that the angle is going to be a special angle. The reference angle is going to be a special angle. So that means 30, 60, and 45. And neither 30, 60, or 45 has a negative sign. So we're going to calculate the absolute value of the square root of 3 or 2. And obviously, the absolute value of the square root of 3 over 2 of negative square root of 3 over 2 is the square root of 3 over 2. So now that I know that it is the square root of 3 over 2, now I make reference. Remember, you should know this. You should memorize this. Definitely you should memorize this, especially if you're going to continue taking other trigonometry courses. But in the meantime, you can make reference to your book. Now, which angle, which special angle has a sign or what sine of a special angle equals the square root of 3 over 2? Well, that would be the sine of 60. If I look or make reference to I believe in chapter 1, to the special angles, we know that the sine of 60 equals the square root of 3 over 2. So I know that 60 is definitely going to be the reference angle. So I know the sine of 60 is the square root of 3 over 2. So now in our third step, all I need to do is just find the angles. Now, I know that sine is going to be negative in quadrant 3 and in quadrant 4. So to visualize this a little better, one of the things you could do is obviously draw your Cartesian plane. And you know that this angle is 90. That this is 180. We know that this is 270 down here. And of course, the initial side is 0 and 360, right? So this will be either 0 or 360 degrees because a full rotation ends in the same place that it started. So now I know for a fact that the sine is negative in quadrant 3 and quadrant 4. So this is quadrant 3 down here. And this is quadrant 4. So this is just to help me visualize where my answer is going to be. So if I'm looking at quadrant 3, and we go back to the reference angles, reviewing the video that we did yesterday, we know that in quadrant 3, the reference angle is 60. So I'm going to take, the first thing I'm going to do is I'm going to take 180, which is the reference angle for quadrant 3, and we're going to add it to 60. So we're going to take 180 and we're going to add it to 60, because we know that if the sine is negative in quadrant 3 and if the terminal side of the angle, that would mean that the terminal side of the angle is in quadrant 3. So we add that, and I know that whenever the terminal side is 240 degrees, that, ladies and gentlemen, is going to have a sine of the negative square root of 3 over 2. And the other one, we know that it's in quadrant 4. And of course, in quadrant 4, the reference angle is 360. So we're going to take 360, which is the reference angle, or which is the angle that we use in that case, because this is in quadrant 4 and it's close to 360. And we subtract it to 60 degrees, which is the reference angle that we obtain. And we know that 360 degrees minus 60 is 300. So that means that the sine of z will equal to the negative square root of 3 over 2 when the terminal side is at 240 degrees and 300 degrees. So hopefully, guys, this video will summarize those two examples and you guys will understand this material without any problems. So until our next class, stay safe and bye-bye.